When we talk about making AI more powerful, our minds usually jump to two things: building bigger models and throwing more computers at the problem. But what if I told you the biggest breakthroughs right now aren't coming from more brute force, but from being smarter? Today, we're pulling back the curtain on the secret ingredient that is completely changing the game.
So let's just get right into it. If you had to guess what makes an AI like Lama or Mistral so incredibly good, what would you say? Probably the model's size, right? Or the absolutely mind-boggling amount of computer power they use for training. And look, you wouldn't be wrong. But that's not the whole story, not even close.
Because the real revolution, the thing that's making AI smarter and way more efficient, is happening at a much more fundamental level. It's happening in the training data itself. For years, the mantra was just more, more, more. But now, we're seeing that a scientific, precise approach to the data is unlocking levels of performance we didn't think were possible with this kind of efficiency. Okay, so here's our game plan. First, we're going to tackle the big mess that is the current AI data dilemma. Then, we'll look at a brilliant new benchmark designed to clean it all up. After that, we'll get to the really stunning results. And finally, we'll talk about what this means for the future of how we build AI.
All right, Section 1. Let's talk about the AI data dilemma. Because right now, the world of AI training data is basically the Wild West. Everybody's got their own secret sauce, their own hidden recipes. It's chaotic, it's unscientific, and it makes it almost impossible to figure out what actually works.
And this chaos creates some really huge problems. You've got a total lack of controlled apples-to-apples comparisons. Is a new model performing better because its data was amazing, or because it had a different architecture? Or maybe they just used way more GPUs? Who knows? And it's getting worse, because even so-called open models are keeping their training data a complete secret. It's a black box, and that holds back progress for the entire community.
And that's really the core of it. We're stuck in this state of confusion. Researchers are trying to build on each other's work, but they can't isolate the one variable that might matter most: the data. It means we're wasting a truly immense amount of resources just spinning our wheels without a deep understanding of why one model succeeds and another one doesn't.
Okay, so how do we fix this mess? Well, a huge team of researchers from places like the University of Washington, Apple, and Tel Aviv University came together to build a solution. It's called DataComp for Language Models, or DCLM for short.
The easiest way to think about DCLM is to imagine it's a standardized racetrack for data. It locks in all the other variables. You use the same car, the same driver, you race on the same day with the same weather. This means you can finally test the one thing you care about, the fuel. In this race, the data is the fuel, and we can finally see whose blend is best.
And the workflow itself is just beautifully simple and scientific. It's a four-step process. Step 1, you pick your scale: small, medium, or large models. Step 2, you propose a dataset. You can do this by filtering a giant pool of data they provide. Step 3, you train a standard model using a fixed, unchangeable training recipe. And finally, Step 4, you evaluate your model on a whole battery of 53 different tasks to see how well your data actually performed. It's rigorous.
And the scale here is, well, it's hard to even wrap your head around. The starting point for DCLM is a pool of 240 trillion tokens of raw data from the web. Think of it like this. They give you a mountain of dirt and sand, and your job is to be a prospector, sifting through it all to find those tiny, precious flecks of gold, the super high-quality data that will make your AI shine.
So to get the ball rolling, the DCLM team created their own house dataset called DCLM Baseline, and they built it with a really smart three-step pipeline. First, something called heuristic cleaning, which is basically just a fancy way of saying they used common sense rules to get rid of spam and other junk. Second, they got super aggressive with deduplication to make sure the data was diverse. And third, and this is kind of the secret sauce, they used another AI, a simple classifier, to read everything and pick out only the best of the best documents.
So did it work? Did this whole scientific, painstaking process actually pay off? Oh yeah, the results are nothing short of a game changer. They prove, without a doubt, that when it comes to data, better is so much more important than just bigger.
Just look at the numbers. The model trained on their DCLM baseline dataset, which is completely open, by the way, hits a 63.7% on this big MMLU benchmark. Now, not only does that blow past the previous open data record holder, it's right up there competing with giants like Mistral and even Lama III, which, get this, was trained on nearly 6 times more data that's kept completely secret.
Let me just put that in perspective for you. This new model achieves a result in the same league as Lama 3's 8 billion parameter model, but it used 6.6 times less computer power to get there. That is a monumental leap in efficiency. It represents an incredible savings in energy, time, and, of course, money.
You know, the researchers themselves really nailed it in their paper with this quote. This proves that a systematic, scientific approach to cleaning and curating your data isn't just a nice little bonus. No, it is absolutely key to training the next generation of truly high-performing language models.
So, what does this all mean for the bigger picture? This data-centric revolution goes way, way beyond just one team building one really good model. This changes things for everyone. The DCLM benchmark has the potential to fundamentally improve the whole field. It makes AI research more scientific, more rigorous. Because it has scales for smaller models, it makes it more accessible, allowing university labs and smaller teams to actually compete and contribute. It makes development more efficient and sustainable. And maybe most importantly, it pushes the entire industry towards transparency and away from this era of secret lockdown datasets.
So if there's one thing you take away from all this, let it be this. The star of the show isn't just the DCLM baseline dataset, as great as it is. The real lasting innovation here is the methodology. It's the creation of a standardized, open, scientific framework that completely changes how we build the very foundation of artificial intelligence.
And that leaves us with a really exciting question, doesn't it? We just saw that by applying some real scientific rigor to data, we unlocked a massive leap in efficiency. It just makes you wonder, what other huge breakthroughs are hiding in plain sight, just waiting for us to challenge our old assumptions and apply this same kind of systematic, scientific thinking?
And there you have it, a deep dive into the new science of AI data. Thanks so much for joining me. Just as a reminder, this is for entertainment purposes only.